morning. This is engineering. I need more power. Kate's operators to power your star fleet. Are there any note takers in the room? If there are, this presentation is already online at github.io/ it's at socketwench.github.io/engineering-I-need-more-power. Give me a thumbs up if any of you have got that down. We're good? Okay, cool. Okay, so you might be wondering, who is this weird person in front of you? Do they get that excited when they have a boarding pass for a business trip, when that was a thing? The answer is, I'm Tess Flynn, otherwise known as Socket Wench. That's Wench, not Wrench. I am a developer, blogger, and educator, and a DevOps engineer at 10.7. 10.7, we make things that matter. We're 100% remote, but we are headquarters in Minneapolis. We do a number of different services from strategy, design, and development. Also, we do support and maintenance, specializing in Drupal and WordPress sites. We're also the creator of Flight Deck, a Kates-powered hosting and local development solution, which is 100% open source. Give us a hi at the wonderful humans at 10.7. So, we know how it is. You're just there with your laptop, chilling in main engineering, checking on your warp core and your antimatter pods. Meanwhile, you and your crew are spiraling down to planet Psi 2000, also known as Planet Impending Operational Disaster, population U. But then the comm panel activates, and it's the captain saying, "Engineering, I need more power." And you have to get this depressed look on your face, and you say, "I cannot do it. I got to have at least 30 minutes. Wait, how long is this talk again? "Engineering, I need warp speed now." And here's the problem. Us as operational people are going to have to do a number of different things to interact with our target application, which relies on our cluster. We're going to have to work with Kate's definitions. We're going to work with supporting applications which live inside of our cluster and external APIs in order to scale up our application. And it's a lot of work to deploy. But what if we were to take all of that knowledge, and take the human being out of the equation? And we take all of that knowledge and we put it inside the cluster in the form of an operator. So what is not an operator? Well, it's not a product, it's not an API, or a library. Let's look at what an operator is. So we have our operator, and we give it a CRD, a custom resource definition. That operator then can turn around and make base Kubernetes definitions, such as stateful sets, deployments, daemon sets, and so on, create pods directly if necessary, or work with external APIs. This is actually only one of the possible cases, but it is, in fact, the most common. You will see this again and again and again when you work with operators. The thing is that an operator is a pattern. It is a resident privileged container which watches for CRDs and performs actions in response to those CRDs. A custom resource definition, a CRD, is a Kate's kind that you define. It's going to allow you to model just the structure necessary for your application, rather than all of the other boilerplate code necessary to make it run in Kubernetes. That simplifies things quite a bit for you. In order to make operators, we can use the Operator Sdk. It is a framework to create operators. It is open source, but it is sponsored by Red Hat. You can get the SDK either through Homebrew on macOS, a GitHub release if you want to go the manual route, or if you're on Linux, you might want to check your system local package manager, as it might already have it available for you. You can find a complete list of the installation instructions at stk.operatorframework.io/docs/installation. What other dependencies do you need to install the operator framework? Well, you're going to need kube control and Docker desktop. You're going to need Golang. If you're going to work with Helm charts at all, you'll need Helm. You'll also need any Ansible dependencies to write an Ansible-based runner, which is what this talk is about. Ansible, Ansible runner, and the OpenShift Python client. All right, we have it installed. Let's make a project. So, in order to initialize that project, we're going to do this command, operator SDK init -- domain, some domain name, some list of plugins. Cool. What's that domain? Well, the domain is not necessarily a web domain. It's actually a namespace for API definitions. SDK calls it an API. It's actually really a kind in Kubernetes. So choosing a domain, personally, shorter is a lot better because the fully qualified domain name for your kinds is going to be kind.group.domain.tld, and it's a lot of stuff. So you might need to play around with this command a few times to get something that looks great to you. How do you choose? I personally like saying the domain is going to be your organization, and also the group is going to be your application. Now, if you're a particularly large organization, it might be subunit instead of organization, so your mileage may vary. What about that plugin switch? That plugin switch specifies the runtime environment for your operator. That can be one of three that's included out of the box: Go, Helm, or Ansible. Golang is going to be the most flexible, but it is the most difficult in order to implement. It's best for new from-scratch operators which have very complex applications. On the other end of the spectrum, there's actually Helm. And Helm is actually the easiest. However, it is the least flexible. It's best when you have an existing chart that you need to add CRD support to. And then there's Ansible, and I love Ansible. It's more flexible than Helm, however, it is less complex than Go. I consider it the middle ground. It's interpreted, not compiled, and it has built-in modules for Kubernetes databases, cloud APIs, and a whole bunch more stuff. It's kind of a batteries-included product. And you might, in fact, already be using it. When should you use the Ansible plugin? Well, if you have an existing CI script that runs on a Jenkins server or GitLab CI or Circle CI or any CI server that invokes Ansible, you can port those existing scripts over to an operator and then power them up with additional CRDs. Or if you have a simpler application which needs stateful changes like a database cluster. When you initialize your project, I suggest you initialize it in a subdirectory, path /my-operator/source. And the reason why is because this will aid in build automation much later. Here's what that directory layout looks like. There's a lot of stuff in here. The config directory is going to have CRDs, schemas, samples. You have the Docker file, which is going to be for the operator container. And then you have a bunch of Ansible stuff. If you actually have worked with Ansible before, that's exactly what that looks like, completely familiar to you. And then finally, there's the watches.yaml, which is going to be your SDK configuration. All right, now we can make a kind. So how do we do that? We're going to do Operator Sdk create API -- group my app -- kind my kind -- generate role. What's this do? It's going to create a CRD template, it's going to update the watches.yaml, and it's going to create an Ansible role provided that you specify -- generate role. What about this CRD schema? One is created for each API, and it's going to be created in config/crd/basis. Now, the structure for this particular schema is actually based on the OpenAPI version 3 schema, like any other Kubernetes custom resource definition, and it has an accept all schema by default. It's good for development, but please don't launch with it. This is actually what that schema file looks like, and the important field here is actually this x Kubernetes preserve unknown fields line, which allows it to accept all by default. Okay. Now, let's actually write the code for our operator. So how do we make sure that we have the proper access to Kubernetes in order to create definitions? Actually, the operator framework does it for us. The operator relies on a service account and a role, and you can actually find the configuration for that in config/crd, and then there's a different file for role binding, role, and service account. The default permissions allow you to work with your CRDs and common Kubernetes definitions, again, stateful sets, deployments, replica sets, all of those normal definitions. However, it doesn't include, for some reason, config maps, so you definitely want to make sure that you only add the permissions that you need and remove any that you don't. Otherwise, Honksly, the space goose, is going to chase you all the way from the galley to the programmer's restroom. What about the input to your role? It's going to pass you the CRD definition that's created, deleted, or edited. And it's passed as an Ansible variable. Here's what it looks like. For the metadata values, you're going to have it in an enclosure, Ansible operator_meta, and then the metadata values. It's not shown here, but labels also show up here as well. This enclosure, the Ansible _operator_meta name, is different in older versions of the SDK because of a naming conflict with newer versions of Ansible. What about the spec values? Those are also exported as Ansible variables, but they're exported as top-level Ansible variables, which makes it a little bit more confusing. It's actually converted for you from YAML standard camel case to snake case or rope case. PHP programmers already know all about snake case. That sample CRD that you want to create, it's going to, let's say we have a sample CRD. Here's what it looks like. It's going to be for a MySQL cluster. It has three variables, MySQL admin secret, MySQL reader secret, and size. Note the camel case. And then when you actually do that in Ansible, it's going to look like this. And you'll notice now they're all in snake case. MySQL underscore admin underscore secret, MySQL underscore readers underscore secret, and size is just size. All right, how do you create or update a Kubernetes definition inside of Ansible? It's actually pretty easy. There's the K8s module, and since your local cluster is already authenticated, you don't need to pass a kubeconfig environment variable or any other weird stuff. It's already done for you. Here's what an actual creation statement looks like. You'll see that we have the K8s module here. Here's the definition, and we're making a service, and we can template it all out as we normally do with any other Ansible, including default variables or transformations or anything else, all the cool Ansible stuff. OK, how do we get this onto the cluster? Well, first we need to build that Docker image, then we're going to need to push it to a registry, then we're going to need to push the definitions to the cluster. First, we need to configure the image and tag. That's going to be set in the makefile. Look for a line that starts with img. Then go ahead and set the full registry URL, and then your operator name, and optionally a tag if you want to set a tag. Then you can build the Docker image. You can do make Docker build in the source directory of your project. This builds and tags the image. It's the equivalent of Docker build and Docker tag. Then you can push it to the registry, Docker log into your registry, whether it's Docker Hub or Quay.io or your personal registry. Then go ahead and do a make Docker push. That just runs Docker push. And then you can apply the definitions. The final line to do that is going to be make deploy. And that's going to template up all your CRDs and everything else necessary to scaffold and run the cluster, and run that through customize and deploy it to your cluster. OK. So how do you deploy a CRD? Well, you can find a sample in config/samples. You can edit that sample, then you just use kubectl apply -f like you normally would. And what that looks like then is that you have your CRD that's going to be passed to the operator. The operator can then create one or more base Kubernetes definitions. This results in new objects. And then the cluster goes, yep, we made some new objects, and it tells the operator that that's what we did. And then the operator says, changed. Change is particularly important for our Ansible. That means that the state of the infrastructure has actually changed. And that's going to become very important in a second. So this is what's called the deployment run. And the deployment run creates new Kubernetes objects, deployment, stateful sets, pods, and so on. All right, that's great. So what? What is it, Mini-Me? Why is this running twice? Oh, yeah, I forgot about that. So after the deployment run, it runs again. So you have a CRD. It gets passed to your operator just like before. The operator makes a number of Kubernetes definitions just like it did before. But because it's the same data, it results in the same objects. The cluster says no changes were made. And then the operator goes, OK. And if you've worked with Ansible before, OK is good. It means that the state of the infrastructure did not change. This is called the Reconcile Run. The Reconcile Run validates the current configuration against the operator, and it means, and you must not have any changed tasks within your code in order for that to run successfully. This means that if you do something as simple as create a temp file, that requires a change status because the state of the infrastructure changed, and thus you get something called a reconcile loop. And that's really bad because then your deploy will never, ever finish. How do you view the results? It's actually really easy. Just go ahead and kubectl edit the CRD that you already deployed. Then look at the status.ansible results section of that definition. So here we have an example of that, and it's looking pretty good. Changed 0, failures 1. That's less good. OK, 9. Unknown playbook failure. Huh. Well, that's not real helpful. What the heck is going on here? How do we actually debug this? Well, what we can do is we can tail our operator container, specifically the manager container within the operator pod. So we're going to do kubectl logs-f operator pod-c manager, and then we can use that to look for the output of our deployment or reconcile runs. And this is where you want to look for deployment loops. Now, in this particular deploy, which I did just Monday, you'll actually notice that here in the output of the manager, we'll find out that I renamed a playbook, and I forgot to change it in the calling playbook, and that was the problem. So there you go, that was the problem, and now we can fix our code, redeploy it. So how do we clean up so that we can redeploy? We can do a make undeploy, and then we have to worry about our finalizers. Right now we haven't set any on our CRDs or custom definitions, but that can cause the make deploy to hang, as we shall see later. Okay, that's great and all. We're just using Kubernetes to make more Kubernetes, but what if we want to do something else? This is what's called a stateful change. A stateful change is any non-Kubernetes resource. That's going to be any on-cluster applications or external APIs. There's no reconcile run when this happens because no K8s definitions were created, so it's not needed. So what happens then, you might have a problem with writing your role. You might need a piece of dependent information. So you get your CRD, it's passed to your operator, and the CRD is saying, make this database on this cluster in this namespace. And the operator is going to go, hey, how do I log into that cluster? And of course, the CRD doesn't care, and of course, the operator can't do anything as a result. So how do you look up definitions within your operator? Well, there's actually a K8s lookup in Ansible. And your local cluster is already authenticated, just like it was with the K8s module before for creating definitions, same deal. So this is what that would look like. You have your CRD, it's passed to your operator. The CRD contains information to spin up a new database cluster. The operator does a lookup. It gets one or more K8s definitions resulting for that particular database cluster. It can get the login secret name from that definition, look up the secret, do another lookup, and then it can query the underlying database pod using the normal, completely boring MySQL_DB module that Ansible provides. And then you get a new database. It's pretty cool. Here's what one of those lookups look like. It's actually really, really long, but you can see it's kind of boring. You have your K8s lookup, the kind is my kind, namespace, and then resource name, and you can use variables for all of these, just as you would expect. Resource name is actually slightly different in newer versions of Ansible. It used to be resource. Again, there's a naming conflict, so that's going to be another hazard you'll have to deal with. So where should you use these lookups? You can use them inline in any Ansible template that you need to use. You can also set task-level var statements if you need to get, say, a default, or you can just use a boring old setFact task. The reason why setFact is OK is because it always evaluates to OK, not changed, so it does not create a reconcile loop. What happens, though, when you have a failed lookup? Well, in the K8s lookup module, what happens is that it returns an empty list, not an empty variable. And it doesn't fail the run when that lookup fails. So you're responsible for the error handling. This is the code fragment that I came up with that actually seems to work pretty well for detecting failed lookups. The name of your variable, piped it through default to return an empty list, and then check to see if the length of the list is less than 1. How do you inform the user if you have a failed lookup or any other failure within your operator? You could use the fail module. It causes the run to fail immediately, and you can set a message to aid debugging. And this message ends up in the CRD status. So you do want to use this module. So here's an example of what that looks like. You can actually see there's a setFact here. We're actually using a var statement here to actually get a default. And then we're going to use the fail module to set a particular nice error message that people can read in our CRD, and then we're going to check that against the length of that query. All right, cool. What about deletions? You need to delete that database. Well, the operator framework does not handle that for you like it did for K8s definitions. So you actually have to handle it yourself. So this is where finalizers come in, and every ops person who's ever had to deal with a stuck delete already is groaning internally. So finalizers run when deleting a case definition, and it's specified in the operator framework in watches.yaml. In Ansible finalizers, you actually can use an existing role, a playbook with custom vars, but my recommendation is to use a new role or playbook. A role is recommended. You can separate it from the creation role, and then you have a separate delegation of responsibilities compared to creation. Now, this does result in some code duplication, particularly if you need to do a lot of lookups. However, it is a lot easier, and you don't have weird conditional statements as a result. Then, how do you create the role? When we actually created our API way back at the beginning of this talk 20 minutes ago, we actually let the operator framework do it for us. However, when we're creating a finalizer, we have to make that role manually. So we have to init it manually, and it's best if you name it after the creation role. And this is what that line looks like: Ansible Galaxy init, path to my operator, and then all the way through the rest of the path, with the name of the creation role underscore finalizer at the end. Then you need to update watches.yaml. This will add the finalizer key to the particular API that you're deleting. Then you point it at the new role. Here's what that looks like. You'll actually see the first few lines there, your version 1, group, kind, and role. That's created from Operator Sdk create API. And here's the stuff that we added manually: finalizer, then under finalizer, name, which is going to be the name of the finalizer, and then role, which is the name of the role in the roles folder. Now, when you do an undeploy, you can actually have some problems, because the thing is that when you do make undeploy, it kills the operator first. This immediately creates a make undeployment loop, and it means that the make undeploy never returns. So you can either delete your custom resource definitions manually, or you can go in and set each one of the finalizer sections for those CRDs to an empty list, and then the delete will complete as normal. Sometimes, however, operator framework's great, but you need extra stuff in order to do stateful changes in your infrastructure. You need extra libraries, extra applications, extra commands, and those need to be in your Docker image. So you need to modify the image. So it's really as any other Docker modification you might have done in the past. You can update the Docker file. The image for the Operator Sdk is based on the Red Hat Universal Base image, which is admittedly a little weird. How do you add libraries to this? It's actually very straightforward. If you've ever worked with Red Hat or CentOS, you can use pip for Python-only libs, or you can actually use yum for everything else. Special thanks to Jeff Geerling for this tip. Here's actually a modified Docker file. You'll notice that this part right here is from the original SDK. Then we actually are going to add stuff to it, so we change to the root user. We're going to download MySQL, and then we're going to install the client and Python libs, and finally switch back to the Ansible user. Okay. So that's all fun, but we definitely are doing way too much work. We would rather just activate the emergency engineering hologram and have it do all of this work for us. So how do we do that? Well, the directory layout helps us here. That source directory makes this a lot easier for us to implement. So first of all, that Docker file, let's look at it. It's nothing fancy. It's a public base image that you can access from anywhere. There's no complex build chain or weird variables or anything. It's really just Docker build, and you're done. So you can build it like any other container. Docker build, Docker tag, Docker push. You can actually put this into Docker Hub with an automated build, Quay.io, or any of your own CI systems necessary to build the container. Here's actually the rules that I used on Docker Hub. As you can tell, these are really boring rules. We have the main branch, which with latest tag. We have a numerical tag source with a source ref for the Docker tag. The Docker files in the root of the directory. The build context is going to be in the /source directory. Boring, 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 as you totally would have expected. What about replacing the make deploy, though? That's a little bit more complicated because that just went to the cluster and things happened and we don't know what it did. Well, there's two different options to getting those definitions onto your cluster. You can use a conventional manifest, or you can use a Helm chart. How do you get that manifest, though? You need to capture the customized output from the make deploy. So we're going to hack the make file. So we have our make file here. You'll find this line in it, which is going to say deploy customize. There's a bunch of gobbledygook. But way at the end here, we actually see the critical line, which is pipe kube control apply dash f dash. And that's actually what we want to replace. We replace that with this. We pipe it to a file. There's your manifest. You're done. What about if you want to use a Helm chart? Now, Helm charts actually have a number of different advantages over a traditional manifest. It's often used to deploy operators because it has templating, versioning, and third-party integrations such as DigitalOcean Marketplace built into it. So that's actually a lot of advantage that you can use there. In order to create your Helm chart, you can actually use that customized output, break it up into several different files according to the standard format for Helm charts, add Helm labels. This is the most difficult part because you do have to add tons of templated labels that Helm requires. So you'll get to know Helm a bit. And then afterwards, you can add that to your project. My recommendation is to actually add it to the charts directory under your root directory, and then the name of your chart after that. Why charts and not chart? Well, you'll see that in a sec. OK, so how do you distribute all of this stuff? Well, you need a Helm repository. And you can, this hosts your chart tarballs by a particular version. You can actually get GitHub to act as a Helm repository. What happens is that GitHub Pages will host the repo, and then the actions will build the chart. How do you configure Pages? It's actually fairly straightforward. You set the GH Pages branch as your Pages branch. Then you empty the branch of all code. You don't want anything in there. Then you need to set up an action. I actually found a plugin online, Helm-GH-Pages, which builds Helm charts on a deploy. Then you can commit that to a GitHub action file under the .github directory. One important detail that I found out is you should override the version in your plugin configuration for this GitHub action. This way you can set the app and the chart version by the Pages tag, and this will ignore the default version that's in chart.yaml, which is 0.1 by default. This is actually what that looks like. There's a lot of stuff in here, but the important parts are going to be the app version and chart version, which is going to default to the tag that we're going to commit, the charts directory, and the branch name. And that's all we need to worry about for that particular workflow. After that, the deployment's actually fairly easy. You're going to commit to the GH Pages branch, you're going to tag it, and you're going to push it. Hub builds the image, and then the action builds the chart. And that's it. Now you have an operator with automated builds, running Ansible code, ready for public distribution. If you want some further reading, there's a number of different places you can go. Introduction to Operators, the Operator Sdk Ansible Quick Start, Helm Chart Getting Started, GitHub as a Helm repo, which tells you how to use that GitHub action to make a GitHub Pages into a Helm repo. And if you want to know how I built this ridiculous Raspberry Pi powered tricorder, you can see my blog post there at the bottom. I also want to give a special thanks for this event for having me here today, 10/7 for sponsoring my time here, and my wonderful patrons on patreon.com/socketwench. Thank you. You can find this presentation on github.io.